Welcome to Agatech Institute of Electronic.
Welcome to Agatech Institute of Electronics. Uh, we have a phone here, Tecno KJ5 Spark 20. The phone is dead. It's dead. It came from another workshop. They removed all the metal shield. What have we tested? We put a DC as usual. You should have known this by now. This is just a flex from battery because ordinary wire will not turn it on. So when we connect it, put our voltage to meter to DC and test VBAT. So when we test VBAT, we have 4.1 volts. Then going to test the uh, power key test point. There's nothing there. There's nothing there. That suggests that maybe our power IC is dead, or maybe power did not get to the power IC. And then when we check, we discovered that power did not get to the power IC. We tested all the capacitors that are there. None of them have any voltage. None of them have any voltage. None. This section that I'm testing now should be a V system. This is the V system. So there's nothing there. So if the power IC is not powered, if the power IC is not powered, there's no way the phone will power on. So what could that mean? There must be a short somewhere, and probably one of the power that comes to the power IC is shorted to ground. So the whole of the V system is gone. You can see there's nothing there. There's nothing there. None of them. So what do we do? Let's quickly set our meter to continuity. So any probe we do is in continuity. One probe to the ground, the other to test the capacitors. Okay, that's short. You can see this is not normal. Okay, this is fine. These are fine. This is short. This is short. You can see that. Oh, this is short. Alright, so these capacitors are short, these ones are short, and these two are short. So what am I supposed to do next? In this case, I'll just put voltage on any of those capacitors to see which of the components will get hot. And on a norm, I will use a thermal camera. I have thermal camera. I use a infrared. But then I don't want to use thermal camera. I want to, for the sake of people that doesn't have thermal camera, I want to use a rosin. I want to use rosin. What will I do? I will put voltage. I will not put a 4.1 volts anyway. I'm not certain of the exact voltage that is on the capacitor I want to use because I'll just pick any capacitor. I'm not using schematic, so I will not use schematic. So I'll just pick any of those capacitor that is shorted. I'll set my voltage to 1.8. 1.8 is good enough. Okay, that's 1.7. So and then I will put on any of those capacitor. I'm interested in this. And if you check, we are happy. The thing is taking 3 amps, so definitely something is getting hot. I will first use my hand. I'm scared. I don't want it to burn my hand. I'll use my finger to feel the board to see what exactly is getting hot. I feel this is getting hot. Let me remove it. Okay. It seems this section is getting hot. Could it be on the other side? It's actually on the other side. It's here. Probably, let's check under the microscope. Maybe above that metal shield or, okay. If you look at that part, you see sign of corrosion. There's sign of corrosion there. So most likely is one of these capacitor that is shorted. So what will I do? I'll just put rosin on all of them. I'll just put rosin on all of them, and then I'll go back to the other side. I'll put the voltage very briefly. I'll put the voltage very, very briefly because it's on the other hand. All right. So you see everything is covered. It become whitish. So when I put the voltage, the component that is shorted will get hot. So when it gets hot, it will melt that atomized rosin, and it will melt. It will melt. So it will be obvious. So, but so that it will not affect every other component around it, I'll just make sure it's a touch. I won't keep it long on it. So the negative wire on the ground, then the positive wire on the capacitor. Just touch. I'll just touch it. Okay. So let's check the other hand. And then nothing melted. Let's check again. This time I'll keep it a bit longer. I'll keep it a bit longer. I'm already thinking it's inside that metal shield. Maybe it's not the component we are, it's not part of the ones that we put rosin. Okay, nothing melted. Most likely it's inside this place. So let's open this metal shield. I was actually thinking this will not take time, but then it's already taking time. So let's quickly. Okay. Okay. It is obvious already. You can see this capacitor. Most likely this is the guy. That's the culprit. So there's I think I think there's no point. But then for sake of documentary, we'll still try and test it. But then let me cool the board down. The board is very hot and it will take time before it will get cool. So let's cool the board down. Okay. Let's clean this. Make sure it's dry so that it immediately rosin touch it, it will melt if it's not dry. So we need to dry it well. Dry it well. So we apply the rosin. We apply the rosin. Okay, that's coated enough. So I'll still use the same 1.7 volts, and like the first time, we will just touch and turn the board back. We'll touch, just a touch. Let me put it under the microscope. So we'll just touch that capacitor, just a touch. Oh, sorry. Okay, you can see it has melted. So this is the culprit. By the time we remove it, the phone should turn on. Let's quickly do that. I'm being nice with this. I can easily use anything to pull it off. All right. I don't want it to spoil the interface because I would like to replace it. All right. We have removed it. So let's see if it's still short. Let's go come with our meter. Okay. The short is gone. You can see the short is gone. The short is gone. So let's quickly test to see if the phone is now working. It should be working now actually. But then the phone is coming from another workshop. Possibly they might have caused another damage. So if not, there's no point testing. It's just to replace that capacitor and pack the phone. But because it's coming from another workshop, someone else worked on it. So we cannot be sure. Okay, probably 4 volts, 4.3. Okay, 4.3 is not bad. All right. So let's test those capacitors again to see if we have voltage anywhere. DC, negative close to ground, and when we check here, we have 4.4 volts. You see. So when we check here, 4.4 volts. So our V system is back. V system is back. So the phone should work now. Let's try and quickly couple it. The fault actually is water damage. If you check the fault that we saw, you saw that there was a corrosion. There was corrosion. Even the first place I was trying to suspect, you will see that there was a corrosion there. So if the water did not get to the screen, if the phone worked, then we are fine. But if the water has gotten to the screen, we might not have display. But at least we will know if the phone or on or not. So let's test the power key. We tested the other time, we didn't have anything. Now what do we have? We have 4.39. So turning it on will just mean pulling the power key to ground. And if you check our DC, most likely the phone is up. Oh, it's not. Let's check again. The phone is on, but there's no display, like I said. But look at the DC. You can see it. The phone is booting already. The phone is booting already. Now that the phone is not displaying, it can mean two things. Probably there's display section problem. The phone is water damage actually. There might be problem with the display section or the LCD is bad. So either of the two. I will not be recording that. What is important is that the board is working. If it's display section, we can easily fix that. And if it is the screen, it can be replaced. The backlight section is actually clean. Where is it? You can see this is the backlight section. It's clean. So this is the IC, this is the diode, and this is the inductor. So the output capacitor, everything is fine. And then now that is on, the phone is on, the voltage that should be out should not be less than probably 12. And we have 16 volts. The backlight is working. The screen is bad. The backlight is working, and I've actually checked did I? Let's check the connector. The connector is fine. The connector is fine. So the screen is bad. Thank you for watching. Please press the like button. Meet you some other time. Bye.